All right, so now we'll move on to the next part of our lesson, adding Poisson distribution. Okay, so if two Poisson variables x and y are independent, then the variable z equal x plus y also has a Poisson distribution. Okay, so this is the next main rule that you are learning. So basically, how to add Poisson distribution. Okay, so if you have two Poisson variables x and y, which are independent, then the variable z, which is the addition of those two independent random variables x and y, will also follow a Poisson distribution. So basically what they're trying to tell you here is if you add two Poisson variables, you end up getting another Poisson variable. Okay, that's what they're trying to tell you. And then let's say, so if x follows a Poisson distribution with mean lambda, okay, and y follows a Poisson distribution with mean mu, then your x plus y, the variable z, which is x plus y, will follow a Poisson distribution with mean lambda plus mu. So very straightforward. So you can directly use the result. Okay, so the proof is not required for you. So you just have to use this result. Okay. Okay. So then we can try to do some questions. I mean, it's really straightforward, right? So we can go through some questions. So in exercise 2D question number 1, they say x and y are independent random variables such that x follows a Poisson distribution with mean 3.3 and y follows a Poisson distribution with mean 2.7. Find part A, the probability x plus y equals 5. Okay, so how do you find the probability of x plus y equals 5? What's the first thing you should do here? So first we know x has a Poisson distribution with mean 3.3, y has a Poisson distribution with mean 2.7. So is there, which is, now here we define z as x plus y. So this x plus y or your z has a Poisson distribution with mean y. The addition, right? 3.3 plus 2.7. So that's the first thing you should do. You should add them and now here your z follows a Poisson distribution with mean 6. Okay, so here basically you have to find the probability that z is equal to 5. So this is very straightforward, right? Probability x plus y equals 5. In other words, it's probability z is equal to 5. Right? So it's really straightforward. So just use the Poisson distribution e to the power minus lambda, lambda to the power x over x factorial. So replace here, your x value is 5, lambda value is 6, right? And it's just a matter of typing in the calculator. And this guy, part B, x plus y is less than or equals 7. So same story, x plus y is z, probability z less than or equals 7. So how do I get this answer? Obviously, I use the Poisson cumulative distribution table. Right? I went to the Poisson cumulative distribution table. I went to the lambda value 6 column and I went to the simple x 7. Okay, in the Poisson cumulative distribution table. So I showed you in the previous videos how to use that table. So it's really straightforward. Go to the table, go to the lambda value 6 column, go to the simple x value 7. Immediately you will have this answer. Okay. And then the next one, probability x plus y greater than 4. So x plus y is my z. Z greater than 4 is, in other words, equal to 1 minus probability z is less than or equal to 4. We know this conversion, right? This conversion I've given it to you guys so plenty of time. Yeah. This conversion, right? So we've used this in binomial. We've used this in this chapter as well. So this one. Okay, x greater than a is 1 minus probability x less than or equal a. And again, this probability, how do I find it? So I find its probability by using the Poisson cumulative distribution table. So again, my lambda value, I go to the lambda value 6, the column with lambda 6, and go to the simple x4, and I get this value, and I get the answer from the calculator. All right, so it's really straightforward. You can see adding Poisson distribution is really easy. The transformation, it's not complicated. Okay. All right, so moving on to the next part, question number 6. So they say here, a taxi company supplies two particular organizations independently. Company A orders taxis at a rate of 1.25 cars per day. Company B orders taxis at a rate of 0.75 cars per day. On a given day, find the probability that two cars are ordered by company A. Okay, so this is just talking about company A, which means you do this in the way we did the previous exercises, right? Just take, so here I'm defining random variable X to be the number of taxis ordered by company A per day. Make sure when you're defining your Poisson random variable, you mention the length of the interval. That's very important, right? So here it's the number of taxis ordered by company A per day, which is having a mean of 1.25 as mentioned in the question. Okay, so it's given. And then we also define the next random variable Y. That's the number of taxis ordered by company B per day. That's also per day. Okay. And then it follows a Poisson distribution with mean 0.75. Okay, so what do I need here? I want to find on a given day the probability that two cars are ordered by company A. So number of cars ordered by company A is random variable X. So I want the probability that capital X is directly 2, right? Because I want to find the probability that two cars are ordered. So probability X equals to is very straightforward. You have the lambda value, you just, and the simple X value. Simply use it on the Poisson distribution function, right? So this is the equation. So you substitute the lambda value as 1.25, X value, simple X value as 2, and you can get your probability, right? So this is really straightforward. And then in part B, they say on a given day, find the probability that the total number of cars ordered by both companies is 2. Can you see? So on a given day, find the probability that the total number of cars ordered by both companies. So what's the total number of cars? So the number of cars ordered by company A is X. Number of cars ordered by company B is Y. So total number of cars ordered by both means, both the companies means we need to add the cars ordered by company A and company B, which is X plus Y. So this total has to be 2, is equal to 2. Can you see? X plus Y is equal to 2. That's the probability you need to find. So let's say Z is equal to X plus Y, and we know Z will follow a Poisson distribution of what? When you add two Poisson random variables, the lambda values just need to be added. So you add 1.25 and 0.75 and it's 2. So basically X plus Y or Z follows a Poisson distribution with lambda 2. And then you are supposed to find what? Find the probability that the total number of cars already is equal to 2. So basically you have to find the probability that Z is equal to 2. Right, so very straightforward. E to the power minus lambda, lambda to the power x over x factorial. Lambda value is now 2. Okay, and the simple x value is also 2. So just substitute and type in the calculator. You should be able to get the answer. Okay. Okay, so those are really straightforward questions. So let's move on to part C. In a given 5-day working week, find the probability that the total number of cars ordered by both companies is less than 10. Okay, guys. So do you see what's happening here? Now you can see here we were defining everything in the X5. They were defined per day, but now here it's a 5-day working week, right? So find the probability that the total number of cars ordered by both companies is less than 10. So if you are going for a 5-day working week, I've told you guys, you give your random variable always with respect to the interval length. Now here X is defined for per day, Y is defined for per day. So if you are going for a 5-day working week, let's define random variables, new random variables for both companies for 5 days. So I'm going to say let capital A be the number of taxis ordered by company A per 5 days. You have to give your length of the interval. And then, per 5 days, the lambda value you should multiply, right? So here A had 1.25 per day. So 1.25 times 5, 6.25 per 5 days. Similarly, the number of taxis ordered by company B per 5 days is, I'm just saying capital B as the random variable. And capital B follows a Poisson distribution. How do I get 3.75? Per day mean for company B was 0.75, 0.75 times 5. That's how I got 3.75. Okay. So what do I need? A plus B. I need the total. A plus B means where when you're taking the random variable A plus B. So A plus B follows a Poisson distribution with mean 6.25 plus 3.75, which is A plus B follows a Poisson distribution with mean 10. Okay, so I'm saying here, okay, A plus B, let it be random variable C. You can use a simple, you can use a letter instead of A plus B, right? Don't use Z because we used Z before, so use a new letter, capital C. So what do I need to find here now? So I have now, you can see I've defined random variables for 5-day intervals, and I've taken the total of the two random variables for the 5 days. Okay, so now what do we need here? So I've done, right, in a given 5-day working week. Okay, so I've switched the random variables, I've switched the lambdas, I've fixed all the stuff. find the probability of the total number of cars, which means you have to add the two companies' variables ordered by both companies, is less than 10. So you have to find the probability that the total number of cars, which is A plus B, right? A is the number of taxis ordered by company A per 5 days. B is the number of taxis ordered by company B per 5 days. So total number of cars per 5 days is A plus B. This needs to be less than 10. This is the probability of finding. So A plus B I just named as C. Let probability C is less than 10. So you know this is random. I mean, this is discrete probability. Less than 10 means C is less than or equal to 9. So what do you do here? Again, this probability, you can get it from the cumulative distribution Poisson table, right? So you go to lambda value of 10, the column with lambda 10, and go to simple x value of 9, and immediately you should get this answer. Okay, so this you should be able to get this answer really easily. Okay. So I hope this part, the addition of Poisson distribution was clear with you guys, because it's really nothing much. It's the same idea as before, just that you need to add your random variables and get the new Poisson distribution and model according to that Poisson distribution. Okay, so the same the concept is similar, just that you're adding your the lambda values. Okay.